limit as x approaches 0 from the square root of 1 plus 9x minus the square root of 1 minus 8x. What I did in the solutions, I just rationalized, and you all went through very easily. So obviously you realize that this is 0 over 0, and I did see some of you tried L'Hopital's rule. Let's see what happens. So when I differentiate this, I get 1 over 2 the square root of 1 plus 9x multiplied by 9. And then minus 1 over 2 the square root of 1 minus 8x multiplied by negative 8. Okay, so far so good. I don't have anything against this. So then we have limit as x approaches 0 from 9 over 2 the square root of 1 plus 9x and plus 4 over the square root of 1 minus 8x. Yep, it's quite all right. So this is 9 over 2 plus 4. Because when x approaches 0, this is 0. So this is 9 over 2. And when x approaches 0, this is 0, and this is 4. So perfectly all right. It works. I just did not apply L'Hopital's rule because the other method seemed to be more straightforward. Good. Anything else? Other questions from anything? Yes? 8a. Good. So limit from cosine x over 1 minus sine x when x approaches pi over 2 from the right. Meaning with angles in the second quadrant. That's what it means. Cosine at pi over 2 is 0. Sine at pi over 2 is 1. So the denominator is 0. The numerator is 0. Perfect for L'Hopital's rule. So limit as x approaches pi over 2 from the right. When I differentiate the top, I get negative sine x. And when I differentiate the denominator, I get negative cosine x. Or limit as x approaches pi over 2 from the right from tangent x. And we know that that would be what? Negative infinity. So when we graph tangent, in the first quadrant is positive, in the second quadrant is negative. Some of you wrote the infinity. I consider it okay, but it's basically negative infinity. At least you were on the right track. Good. Next question. Anything else? So pi over 2 on the right is in the second quadrant where the tangent is negative. Good. Anything else? And few of you forgot that 6 to the x prime is 6 to the x times natural log 6. Please remember that. Anything else from anything? Number 10. Yes, we did number 10 in class, if you go back to the notes, but let's at least get it started. So we're given that the top and bottom margins of a poster are each 6. So 6 and 6 inches. And the side margins are each 4. And we are told that the area of the printed material on the poster is fixed. So this is x times y. So therefore this is x plus 8. And this is y plus 12. So we are given this area as 384. So x times y equals 384. Okay, so we want to find the dimensions of the poster with the smallest area. So that the area of the poster would be x plus 8 multiplied by y plus 12, which is xy plus 8y plus 12x and plus 96. And we do have xy, so this is 384 plus, let's say 12x, and I'm solving this for y. So 384 divided by x. So plus 8 times 384 divided by x and plus 96. So this is the function that we need to use. And I'm going to clean it up a little bit. And what do I get? So I have 480 plus 12x and plus 3072 divided by x. So now this is indeed a function of x, and now I can differentiate and get 12 minus 3072 over x squared. Or 12x squared minus 3072 over x squared. And I'll find the critical number by setting this equal to 0. And I end up having, so a prime equals 0 means 12x squared minus 3072 equals 0. And then x squared is, if I divide by 12, I get 256. And when I take the square root from 256, I get 16 centimeters. Was it centimeters or inches? Let me take a look. Centimeters, yes. Okay, so if x is 16, then I can find y as 384 divided by 16. And I think I get 24. Is that? Yes. So y equals 24 centimeters. But this is not good enough, because I have to show that when x equals 16, this is a minimum. So when I study the sign of this expression, when I plug in 0, I get negative. And when I plug in 20, I get positive. So this is typical for a minimum. But I have to show that. I can't get full credit if I don't show it. So these were the dimensions. So of course the actual dimensions of the poster would be, so the x and y are these, and if you want to determine this and this, you can. But we're asked to determine, yes, so I have to add. So then x plus 8 will be 24, and y plus 12 will be 36. So these are the dimensions of the poster that, keeping in mind that the printed area is 384 centimeters squared, will give us the smallest area, with the smallest area. Okay, other questions? Is there anything else you would like to go back to? Any problem? Number 9. Yeah, we did this problem in class. It was on a quiz. You just have to simplify, and everything is just a couple of lines. So once you simplify and you state that x minus 2 goes away, and the denominator, and so on and so forth. So that's just a couple of lines. So I'm just going to find the first and the second derivatives. So f of x, x minus 2 divided by x minus 2, x minus 1. So the domain will be x not equal 1 and x not equal 2. And then when you simplify, you get x over x minus 1. So the derivatives are just very simple. Not even one line. It's the same problem you had on the previous quiz. So then f prime of x, top prime is 1 minus top over x minus 1 squared. So this is negative 1 over x minus 1 squared, or negative x minus 1 to negative 2. So when you find the second derivative, you have 2 divided by x minus 1 cubed. So the derivative is always less than 0, so the function is always decreasing. And there is no inflection point. There is no the derivative changes sign. The second derivative changes sign, meaning it will be concave up or concave down in different pieces of x value. Is this good enough? Okay. So of course x equals 2. When you plug in 2, you will get 4. What will you get? 2. Yes. So 2 comma 2 is a whole, and x equals 1 is a vertical asymptote. And this function has y equals 1, a horizontal asymptote, after you find the limits. Anything else? Anything else? Anything else? Okay. You can always stop me if you have anything for me. But I would like to go to, if you'd like to start by reviewing the limit of the Riemann sum, I'll be more than happy to start with that. Would you like to start with that? Yes? Felix, would you like to start with that, or no? No. He says no. Okay, then, so in that case, let's go back and finish up this chapter. And I got my pencil ready because I would like us to, I'm sure you're going to encounter something like this. In WebAssign. The velocity graph of a braking car is shown. So this is the velocity. It starts at 70 miles an hour, and it decreases to 0 miles an hour in 6 seconds. Use it to estimate the distance traveled by the car while the brakes are applied. So we want to determine the distance that the car is traveling between 0 and 6 seconds. If I had, let's suppose I had this function v of t, what would I have done to determine the distance covered by the function, by the car between 0 and 6 seconds? I would have determined the definite integral, because I'm going backwards from the velocity to the function, right? So the definite integral from 0 to 6 from v of t dt, which is basically the area, since I don't have the function, it's basically the area under the graph of the velocity between 0 and 6. So we are not given the function, but we are told, use the graph to estimate the distance traveled by the car while the brakes were applied. It's not going to be an easy task. We may be way off, but we have to attempt. So I already see, so this is 1, and this is 20. So I see this area as 20. Another one is 20. Another one is 20 feet, of course. Another one is 20. This one is not 20. This one is not 20. This is smaller. This is a little piece. This is a little piece. This is a piece. So for now I have 20 because it's the area is 1 by 20, right? 20, 40, 60, 80. For now I have 80 feet. So let's see what will you estimate this to be? This piece. And then this piece. And then this piece. And then this piece. And then these. I would roughly like to say that this is roughly half of this rectangle. So 3 times 20. So I'm going to add 15 for all this area. So now I have to estimate 1, 2, 3, 4 pieces. Can I say that this piece is basically here and I get another 20?
You have 15.
It was, I'm sorry, 30 times 20, 60 divided by 2, 30. So, thank you. I was just thinking about that. It cannot be that small. Okay. So now we're here. I'm going to say that this is another 20. So now I have to estimate this piece and this piece. So can I say roughly that these two, they're not the same, they're not equal, but can I say that this is roughly another 20? Approximately. So I'll say 150. So approximately 150 feet. To stop completely from roughly 70 miles an hour to nothing. Any questions? Any questions? Very good. So that was one thing that I did not get the chance to show you from 5.1. How to estimate areas when we need to. Okay. From 5.2, there is nothing that I did not address. I don't see anything in 5.2. There is nothing left to address. From 5.3, we looked at the fundamental theorem of calculus part 1 and part 2. We discussed everything. There is nothing. 5.3 completely done. 5.5 completely done. I do have a little bit of a piece left over from 5.4. That is the last thing. Yes. Okay. So let's take a look. Only one type of problem that I did not get the chance to look at. Okay. So let's say the velocity function in meters per second is given for a particle moving along a line. Find the displacement, which is the function, the displacement function, which is the distance. Oh, I'm sorry. So the velocity function in meters per second is given for a particle moving along a line. Find two things. Part A, the displacement, which is the velocity, which is the distance function as a function, to be exact, the most general antiderivative. And part B, find the distance traveled by the particle during the given time interval. And we have a given time interval. So please choose 59 or 60. Perfect. So let's take a look. So problem 60 on page 405, we are given the velocity. Let's copy it. T squared minus 2t minus 8. And we are given the interval 1, 6 for t in seconds. And we are asked part A. Part A is the displacement in other words, s of t, in other words, the indefinite integral from v of t dt, in other words, the integral from t squared minus 2t minus 8 dt, which is the most general antiderivative of function v of t. Can anyone steer us in the right direction? T cubed divided by 3 minus 2t squared over 2 minus 8t plus a constant c. Yes, we can clean it up a little bit as t cubed over 3 minus t squared minus 8t plus a constant c. So that was just a displacement we were asked to find find displacement and distance traveled during the given time interval. Now, if I want to determine during the time interval that I'm given, because we may interpret that as a displacement between those two, then s of t will be the integral from 1 to 6 from v of t dt. In this case, all I have to do is use what I just determined, t cubed over 3 minus t squared minus 8t from 1 to 6. And then we plug in 6, 36, 48, minus when we plug in 1, 1/3 minus 1 minus 8. So the first fraction is, and I divide by 3. $72 minus 84 minus 1/3 and plus 9. Okay, so this is 81. Minus 84 is negative 3 minus 1/3. So this is negative 10/3. What does this mean? It means that the particle moved towards the left by negative 10/3 feet. Now we're also asked to find the total distance covered by the particle. In other words, we have to accumulate the distance as we did a long time ago in chapter 3, I believe it was, with that particle and the velocity and between such and such, right, and acceleration, etc. But this time when we are asked in part B to find the total distance is the integral from, in general, from t1 to t2, from the absolute value of t dt. We could have determined the total distance when we talked about it last time, but we didn't know integrals then. So we could have used this formula. So now how do I use this to determine the total distance covered? So this is the integral from 1 to 6 from the absolute value of v of t dt. So first I have to start with the velocity function in absolute value. It was t squared, right? Minus 2t minus 8, yeah. Okay, what are the options? All absolute values have two options. One for t squared minus 2t minus 8 if, and you'll tell me what, and the other option as negative 2t squared plus 2t plus 8 if something else. If what? Not x, not t, not x, not t. Yes, if t squared minus 2t minus 8 is greater or equal to 0, indeed. And the second possibility, right. But now we have to dig deep. How do I solve this inequality? Once I solve this inequality, I'm almost done. But how do I solve that inequality? I have to factor awesome. T minus 4, t plus 2, and I have to use that table. Or any other method that you prefer. From negative infinity to infinity, I put in t minus 4. I study the sign of t minus 4. I study the sign of t plus 2. And I have to study the sign of the product. Okay, which numbers go into the table? Only two numbers. The 0 for this and the 0 for this. In ascending order, of course. So first negative 2 and then 4. 0, 0. Both are linear functions with a positive slope. When I multiply two negatives, when I multiply a negative and a positive, when I multiply two positives. So now I know the answer. I'm going to write it one more time. So the absolute value of v of t is t squared minus 2t minus 8 for t between negative infinity and negative 2 union 4 to infinity. So t in the interval negative infinity and negative 2 union 4 to infinity. And it's negative t squared plus 2t plus 8 when? When t is in the interval? Yes. Using the properties of the definite integral now, I need to determine the integral, so the total distance, the integral from 1 to 6 from the absolute value of v of t dt. So it's definitely a sum of two integrals. Can anyone tell us what to write? Yes? We only have 1 to 6. I cannot start with any negatives. I only have 1 to 6. And there is a break at 4. 1 to 4, of course, dt, and the other one from 4 to 6. But now I have to be careful which function goes here and which function goes here. Of course, dt must be in the problem, otherwise there is nothing. Which function I use from 1 to 4? From 1 to 4, negative t squared plus 2t plus 8. And from 4 to 6, yes. This is guaranteed to give us the total distance of the particle because, as you know, it can go back and forth, positive, negative velocity, but it still accumulates distance. Ready? So then negative t cubed over 3 plus 2t squared over 2 plus at from 1 to 4 plus, same thing, but signs are changed, minus 2t squared over 2 plus 8t from 4 to 6. Upon determining these integrals, we determine the total distance. Any questions? Any questions before we continue? Is this okay? Yes, Matt?
Second one, t squared over 3 is
My apologies. Don't trust me today. Anything can happen. So a negative 4 to the third over 3 plus 16 plus 32. Minus when I plug in 1, negative 1/3 plus 1 plus 8 plus when I plug in 6, oops, okay, plus when I plug in 6, 6 to the third over 3 minus 36, 48 minus when I plug in 4, don't trust me today. I repeat. Okay. So 4 to the third, I think it's still 64. 16 times 4. This is positive, I'm sorry, I'm here. This is positive 48. This is positive 1/3, but this is 9 minus 9 plus. What did I get before for this? What was it? It's the same number. What did I get? 72, right? Yeah. So this is 72. This is positive 12. This is negative 64 over 3. This is 16 with minus in front. Okay, so this is negative 128 over 3. Oh, plus 1/3. That's nice. Oh, yeah. Okay, now I have 72 and 12 and 48. 72 plus 12, 84, and then 48. 132 and minus 16. I got 116. Correct me if I'm wrong. And I disregarded a negative 9. I did not include the negative 9 yet. Yes. Okay. So negative 127 over 3 and plus 107. And negative 127 plus 321 over 3. So how much is 321 minus 127? I got 194 divided by 3. Do you expect a positive number, a negative number, or anything can happen? Number one, I cannot cover a negative distance. I could never say to you that from point A to point B, I drove negative 5 miles. Number one. Number two, this is time, and this is an absolute value. So this is a positive function no matter what. Even if the velocity is negative, when I apply the absolute value, this will always be positive. As long as this function is positive, the answer for the area will always be positive. And we're talking about time. So, of course, we expect a positive value, 194 over 3. Did I calculate, did I get those numbers correctly? I'm more than willing to do it again. So, negative 128, that's correct. So I have 48 and minus 9 plus 72 and plus 12 and minus 16. So I did get 107. And then times 3. And then I subtract 127. And I got a 194 over 3. Questions? Any questions? There is nothing else from this chapter. I'm ready to start the review. Any preference what to start with? So maybe I should list the topics that you will see, right? Okay, so let's talk about the topics for test 4. Say it again. Oh, we haven't decided yet. We will. After I list the topics, we will discuss and decide together. So, of course, antiderivatives. Riemann sum. Only for linear, quadratic, and cubic. Nothing else. Definite. Indefinite. Definite and indefinite integrals. Substitution rule. Substitution rule. Total distance that we looked at today. I'm looking at the review because I don't want to forget in the book, so I don't forget any type of problem. Properties of integral, of definite integral. And fundamental theorem of calculus part 2, or part 1. The one with g of x being the integral from a to x from f of t dt. There is nothing else. These are all topics for this test. This is it. So properties of definite integrals. We had a couple of examples in which we were asked to show that a certain inequality holds without determining anything. This is it. Now you tell me what you would like to start with. And also, since we do not have a class Wednesday next week, we do have a class Wednesday this week and Monday next week. And then we meet again in December. So today, Wednesday, Monday, and 2 meetings in December, and then the final exam. So 3 meetings plus 2 more, 5 meetings total plus final exam. So when would you like us to take test 4? I don't mind to take it before, I don't mind to take it after, it's up to you. Thanksgiving. But if we take it on the 2nd, then we will only have 1 session to review, 1 meeting to review for the final. We may try to squeeze in a total review again. Between now, there are 3 weeks left, basically somewhat less than 3 weeks. I would recommend we do all tests with solutions as frequently as possible in preparation for the final. So when would you like to have test 4? Any suggestions? I don't want to spend too much time on this. If you still need time to think about it, you can tell me on Wednesday, but I'd like to make a decision though.
After break?
After Thanksgiving?
Yeah.
I don't have a problem with that. Are you okay with reviewing just 1 session, potentially an additional session for the final?
Yeah.
Maybe that Monday night or something like that before the final? Would you agree? Is everyone okay with that? Other suggestions? Elizabeth, what would you like? Wednesday before break? I wish. Yes, we do not have that Wednesday before Thanksgiving, we close at 4. So my 5 o'clock class and your class will be canceled. Okay? Monday then? If you'd like to take it before the break, Thanksgiving, I can send it to you for you in the testing center. Just let me know. I have no problem with that. if you want to take it early, and then you don't have to come on Monday because we're going to take the test. It's up to you. Okay, so for now we'll say December the 2nd, I think it is. Is it? Can anyone help? Is December the 2nd on that Monday? No, it's not December the 2nd, is it?
The date is December the 2nd.
Yeah, the 2nd, right?
Yes, ma'am.
Okay, very good. So then test 4, December the 2nd. If you want it earlier, you have to let me know ahead of time, and I will put the test for you in the testing center. No problem. Okay? I would like us to all take it together if possible, because I'm here if there is any question you may have, but it doesn't matter. It's up to you. Okay, so which topic would you like to start with?
Can we go over the FTC part one?
Yes, very good. So let's take a look. Here it is, problem 48. On page 417, we are given a function in the form of an integral from 2x to 3x plus 1 from sine, I think it's t to the 4th, yes, t to the 4th dt. We are only asked to find y prime. This is the question. Find y prime. We're not asked to evaluate. We can't evaluate anything here. So we are only asked to find the derivative. Showing, in other words, that differentiation and integration are inverse operations. So then now, question is this prepped? Is this clear? Is it done before I differentiate? Or you can say, no, it's not done because you need to do A, B, C, D, E, F, G.
No.
Say it again.
I said no, it's not going.
It's not done, correct. Of course not. Because it has to look like this. A number and something, or x. So then one of the properties of the definite integral allows us to split the integral to any number. And we have to do that because the fundamental theorem of calculus part 1 is not applicable if the lower limit is not a number. So, of course, this must be sine t to the 4th. There is no change there. This is ready for differentiation, but this one is not. There is another property of the definite integral that allows us to swap the limits of integration, but all that happens is it changes its sign. Now this is fully ready for differentiation. One more time, this is a function given in a form of an integral. So now when we differentiate and we get y prime, what happens when I differentiate this piece and what happens when I differentiate? Because we're differentiating a sum. So when I differentiate a sum, I get the first derivative plus the second derivative. The derivative of the first piece plus the derivative of the second piece. So what do I have to write next? I copy the negative sign. I copy sine, but what do I have inside? It must be 2x to the 4th power. And then I have to differentiate by the inner function, which is 2. If it were just x, I would have written just sine x to the 4th and nothing else, because x prime is 1. But since this is not a plane, not plain x, but a function of x twice x, then I have to differentiate by the inner function prime. And now plus. We differentiate the second integral. The integral and dt disappear. And we get plus sine 3x plus 1 to the 4th times the inner function prime, which is 3. Of course, I will not expand this, but I can multiply or take this to the 4th power, in other words, and I will write a negative 2, put the 2 in front, sine of 16x to the fourth. And then plus 3, sine 3x plus 1 to the fourth. And it's done. So we were given a function as in the form of an integral. We were asked to differentiate it. But it needed some prep, because the fundamental theorem of calculus cannot be applied, in other words, if this is not a number, and this can be x or a function of x. So this was the fundamental theorem of calculus part 1. Let's think of the next step. We're going to review again on Wednesday and again on Monday. Everything again. But right now, please choose the next topic. What would you like? Riemann sum. Please choose a function and choose an interval. Any function that is linear, quadratic, or cubic. So give us f of x. Give us an interval. And we will determine the area as the limit as n approaches infinity from the sum from I equals 1 through n, delta x f of xi. And we will also determine it to check the integral from a to b from f of x dx. So we need to choose a function, linear, quadratic, cubic, and we need to choose an interval. Now, if you want to be nice, you will choose an interval that starts at 0. If you want more work, I should say, then we start anywhere else, not at 1. And not at 0, but at 1 or 2 or 3. Okay, very good. 3 to what? Three to 6. And now let's choose a function. So we know that we want to determine the integral from, in other words, from 3 to 6 from f of x dx, but we have to pick the function. Since we started at 3, we can use a linear function. That would be nice, too. But it doesn't matter. You choose the function, any function you want. Do not say sine x, because we can't. You not say e to the x, because we can't. At this stage, we only have linear, quadratic, or cubic. If you choose cubic, we're going to spend half an hour on it.
Can we do something like x squared just to kind of compare it to what we did before?
Yes. Yes. So let's say x squared plus 2. Good. So remember the preps. I cannot start the limit of the Riemann sum before I determine 3 different quantities. What is the first quantity that I have to determine? Yes, it's this one. This piece needs to be determined first. Delta x by definition is 6 minus 3 over n. So I'm done with this. But now I need this inside. And then this. But I have to find this in order to find this. So I need xi. We start at 3. And we want somewhere to have xi. What is xi? What does xi equal to? Equals 3 plus how many delta x's? If this is 1, is 3 plus delta x. If this is 2, is 3 plus twice delta x. If this is 5, is 3 plus 5 delta x. If this is I, this must be 3 plus I delta x. Good. So 3 plus delta x is 3 over n times I. 3i over n. Good. Final step, I need this, which is f of 3 plus 3i over n. I need to determine f of xi, and then I can put everything together. So I started with this, then I continued with the inside. now I'm determining this, and then I have all the pieces to put together. Good. So you said x squared. So 3 plus 3i over n squared n plus 2. Since the function is positive for sure, do you expect a positive area or a negative area? Of course positive, right? If the function is positive, the area will be positive. Good. So then I square 9 plus 2 times the first times the second. 18i over n plus 9i squared over n squared plus 2. So when I square a binomial, I get 3 terms. The first term squared plus 2 times the first times the second plus the second term squared and plus 2. Any questions so far? In descending order, clean it up as much as possible. 9i squared over n squared plus 18i over n and plus 11. If I don't do those preps first before I put everything in the limit of the Riemann sum, it will take like forever because I have to simplify, I have to plug it in, etc., etc. So now I'm ready. Now I will say the area, the exact area equals the limit as n approaches infinity from. We know already that delta x is a constant. I would like to not waste time or paper and put it outside already. So that is 3 over n. Then I know that I have 3 terms and I have a sum. So I will write the sum from 9i squared over n squared plus the sum of 18i over n plus the sum of 11. It cuts back on writing a little bit. So I should have written the sum of those 3 terms. But I went directly to writing the sum of the first term plus the sum of the second term plus the sum of the third. Of course, from I equals 1 through n. Now I have to use another property of the sigma or summation notation, which again, we already used once. I take the constant in front, like we just did with delta x. So this equals now limit as x approaches infinity 3 over n, 9 over n squared, the sum of I squared. This is the ugly one. n plus 1, 2n plus 1 divided by 6 plus 18 over n, the sum of I, n plus 1 over 2 plus 11, the sum of 1, which is n. If you visualize, if you can, you don't have to, but if you visualize this, you're going to cut back on writing a little bit and on time used on this problem. Now, before you start simplifying, look at all those fractions and decide about the least common denominator. So if I simplify by 3, I still have the 2 in the denominator. So there is no point in simplifying the 2 with 18, because the denominator will still be 2n. I will simplify by 3 and by n, and the denominator will be 2n. The denominator is 2n. This one has 1, needs to be multiplied by 2n. So let's do that. I'll simplify, and I'll simplify by 3. So this is limit n approaches infinity. 3 over n still outside. 2n as the least common denominator. And this one needs a 2n. Okay, 2n in the denominator, but 3 multiply to these two. I will multiply here as 2n squared plus 3n plus 1 because it's easier to multiply by 3. And I get 6n squared plus 9n plus 3. Plus, I will distribute here and get 18n squared plus 18n. And I multiply here and get 22. I meant 22n squared. So Now I have to present everything at the top in descending order. I see a 22 and I see an 18, and that's 40, and then 46 n squared. Limit as n approaches infinity to n squared, 40, 46. Don't forget a 3 in front, plus 27 n and plus 3. Right this moment I can stop and write the answer if I wanted to. So the top, degree 2. The bottom, degree 2. The limit goes into infinity. So then 46 divided by 2 would be 23, and 23 multiplied by 3 would be 46. You can say, I don't remember this, use L'Hopital's rule. Because it's infinity over infinity, I would use L'Hopital's rule twice, and I'll still get the same answer. Would you like me to write the answer, or would you like me to show L'Hopital's rule? L'Hopital's rule, very good. So, here we have we agree that it's infinity over infinity, correct? Perfect. So limit as n approaches infinity from 3 is outside. It can stay outside of limit. I don't care. So maybe I should put it outside so it's not confusing. It's a factor. Can go outside and wait patiently. Okay, so I differentiate this and I get 92 n plus 27 over 4n. Again, it's infinity over infinity. So 3 limit n approaches infinity from 92 over 4, which is 3 times, when I simplify by 4, I get, no, I can't simplify by 4. Okay, 46 divided by 2. So what did I do here? Hold on. What did I do? So 23 times 3. So it's 46. Oh, yeah. I'm sorry. Yes, I can. So I said, don't trust me tonight. So the same thing, 46, 49. Yes, 49. 49. Right? 23 times 3, 49. Say it again. Yes, as I said, don't trust me tonight. Anything. So I was going to check right now. So the integral from 3 to 6 we decided, and it was x squared plus 2 dx. Good. So this is x cubed over 3 from 3 to 6 plus 2x from 3 to 6. I don't have to split it like that, but so this is 6 to the third divided by 3, which we already know. Now I'm going to dream about this number, 72. And then when I subtract, when I have 27 over 3, which is 9, plus 12 and minus 6. Okay, let's see what we get. So so this is negative 15, so this is minus 3, and of course 69 as we expected. So with practice, if you practice just at least the problems we did in class, you should be able to finish this problem quite quickly. And no, I don't think I am going to choose an interval that does not start at 0. That's if you get the answer correctly with an interval that starts at 0, and if you don't with an interval that doesn't start at 0, it's only the algebra that you probably messed up. So, but it will become too long if we don't start at 0. So I prefer to start at 0. The interval will start at 0. Good. So let's go back and choose the next topic that you would like to review right now. So here they are again. So we looked at the total distance just a minute ago. We looked at Riemann Sum. what would you like to continue with?